So here is a very small summary regarding our determinants of elasticity. That is, demand tend to be more elastic if we can find out large number of close substitute, if the good is luxury, if the market is narrowly defined, and there is a longer time period. So I have pasted a small video for your interest, and you need to find out that whether the demand is elastic or inelastic. So let's watch that.
Hi everybody, it's Dr. McGlass and I'm here for my weekly fill-up on my car. You may have noticed that gas prices tend to fluctuate a lot. Today I'm looking at 272.9 a gallon, and the question is, am I going to react very much to that? One thing that I didn't address in my video that you watched on elasticity is the characteristics that determine elasticity of demand. One of them is the product a luxury or necessity? Well, for me, I need to drive to work, I need to drive to get my daughter to school, I need to drop her off at the babysitter, so I have to have the gasoline. So my demand would be inelastic. The second one would be, are there a lot of substitutes for gasoline? And frankly, for my old car, 1997, it's not going to run on anything but gas, so I don't have any substitute goods that I could purchase. The third one would be, what's the share in my budget? Now, for other people, this may be different if they make less money than I do, but I do have a doctorate, I do have a pretty good job, and the gas prices aren't a huge share in my budget, so it doesn't make a big difference when the prices fluctuate a bit. The last one is time. How much time is available to make the purchase? When I am running on empty, I don't have a lot of time to think about it, so I need to get my gasoline and I'm not going to worry about the price. So you tell me, is my demand going to be elastic or inelastic?
Okay, if your answer is inelastic, then you are in good shape. Okay, now we have a practice question here in order to test your knowledge that we are on the same page. So please answer the following question. Pause the video, try to solve it by yourself, and then compare it with the answer. Okay, here, pause the video and compare it at the end for your answer. Okay, now we'll start computing the price elasticity of demand. So the price elasticity of demand is computed as percentage change in quantity divided by percentage change in price, which means percentage change in quantity demanded divided by percentage change in price. And how we can find out the percentage change? New value minus old value divided by old. So let's discuss it. So the method to use percentage change of the formula of new minus old divided by old is erroneous. How? Let's explore this. So, so we have two point A and B. On point A, price is 4 and quantity is 120. On point B, price is 6 and quantity is 80. So let's talk about that. What is the percentage change from A to B? From A to B, right? So if we talk about A to B, then B is the new price. So what is the percentage change? New minus old divided by old, which is 6 minus 4 divided by 4. Answer is 50%. While the quantity is new minus old divided by old. Answer is 33.3%. Similarly, when we move from B to A, the percentage change in price, it would be new value would be 4, old value would be 6. So 4 minus 6 divided by 6. Answer is 33%. While quantity is 120 minus 80 divided by 80. Answer is 50%. So let me just remove it. So if you see that even the percentage changes, they are not equal. See? So let's talk about the price elasticity of demand here. So the price elasticity of demand, when we just using the formula, that percentage change in quantity divided by percentage change in price. From A to B it's 0.66, from B to A it's 1.5. So you see the answers, price elasticity of demand from A to B is 0.66, which is not equal to 1.5. So that formula is not a good calculation. So to remove this annoying problem, the economists developed midpoint formula, which is a better way to calculate percentage change in and elasticity. So what is that formula? The formula for percentage change is new value minus old. Instead of dividing with old, we just take a midpoint. That is. So the formula for price elasticity of demand, it is percentage change in quantity divided by percentage change in price. And how we calculate the percentage change in quantity? New quantity minus old divided by the midpoint. How we calculate the percentage change in price? New price minus old price divided by the midpoint, right? So by doing this, we can eliminate the problem from A to B and B to A. So we have the example. Whenever there is a question, please use midpoint formula as a default formula. It means you don't need to use this formula to calculate the percentage change, because this will result in error. Okay, so I just want you to pause the video, and through midpoint formula please find out the price elasticity of demand. Okay, just pause the video and I will be pasting the answer in a short while. Okay, here this is the answer. If your answer is 2.32, you are in a good shape. So one question that should be popped in your mind is that where this negative goes, because we are talking about price elasticity of demand, and according to law of demand, price has inverse relationship with quantity. So it is natural that the answer is negative, right? And what does this 2.32 means? It means if there is a change in price, 1% change in price, it will cause to decrease in the price how much? 2.32%, right? So even if you ignore this negative sign, it automatically means that it will be, if price increase, quantity will decrease. Okay, if you let it happen here for -2, answer is good. Okay, I have pasted a practice question for you guys. So I'm just going to pause the video here. You too pause the video and try to read and select the best answer, and at the end match the answer. Okay, if your answer is C, you are in good shape. You understand that. How? Because if the price elasticity of demand for a good is 1.65, then 3% decrease in the price will result, of course, 1.65 multiplied by 3, answer would be 4.95%, right?